The chapter Sum Application of Trigonometry, we are going to see another module, and here we are going to do a sum based on application of trigonometry. It's going to be very easy, very interesting. Let's see the sum. It says that a kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string, assuming that there is no slack in the string. Now we read the question. Let's understand this sum. Let's break it into small pieces and then understand. It's very easy. It says the kite is flying at a height of 60 meters above the ground, right? And the string attached to the kite is temporarily tied to the ground. So we have a scene like this. This is what we have, right? And the kite is at a height of 60 meters above the ground. That means the distance of that kite from the ground, when we talk about the distance, it is a perpendicular distance, and that distance is given as 60 meters. So this is what we have right now. What they say is that inclination of the string with the ground is 60 degrees. Now when we say inclination, inclination means the angle. So we are saying inclination of the string means the angle made by the string with the ground. So the angle made by the string with the ground, this angle is given as 60 degrees. The next question they ask is find the length of the string. So we are supposed to find the length of that particular string, right? Assuming that there is no slack in the string, that means there is no bend in between the string. It is perfectly straight, right? And assuming that we have to find the length of that string. So let's say we have a right angle triangle ABC. Are you going to draw a kite and like this ground? No. You're just going to draw a right angle triangle ABC. So that means this is what you're supposed to draw. So now you understood what you have to draw. Now we have to describe the figure. Yes. So now let's start with the description. So here we'll write that here AB represents the distance of the kite from the ground. Beautiful. And we know that AB is equal to 60 meters. Then we know that this AC, what is AC? AC represents the length of the string, and we have angle ACB given to us as 60 degrees. Now this is the information which we have. This is a given information. We have described the figure. Now we move ahead. We need to find AC. Now how are we going to do that? It's very simple. I said first search for a right angle triangle. Do we have a right angle triangle? Yes. In that search for the acute angle there. What is the acute angle given to us? It is ACB, which is 60 degrees. Now for this angle C, observe what is given to us. We have the opposite side AB given to us. And what are we supposed to find? We need to find hypotenuse there, which is nothing but AC. So we are talking about a ratio involving opposite side and hypotenuse. So students, what is the ratio which comes to your mind when we talk about opposite side and hypotenuse? Yes, we know that it is nothing but it is a sine ratio. So we're going to apply sine to this particular angle, that is 60 degrees. So let's do that. So in this right angle triangle ABC, we write sine of 60 degrees is equal to opposite side upon the hypotenuse, means it is AB upon AC. So now from the trigonometric table, we know the value of sine 60 is nothing but it is root 3 upon 2. So we substitute that value there, right? So we write root 3 upon 2. Is equal to AB, the value of AB. Do we know the value of AB? Yes, we know it is 60. So substitute that. And the value of AC, we don't know. Keep it as it is. That is what you are supposed to find, right? Now let's do the cross multiplication. So we have AC on one side. So we get AC is equal to 60 into 2 upon root 3. And 60 into 2 is nothing but we have it as 120 upon root 3. Now students, here the denominator which we have in this fraction here, that denominator is an irrational number. So whenever you have an irrational number as a denominator, you need to rationalize the denominator. And for rationalizing this, we are going to multiply the denominator by root 3 and also the numerator by root 3. Now we get there 120 upon root 3. So now we multiply and divide by root 3, right? So into root 3 upon root 3, right? Beautiful. So now what happens in the denominator? So we have 120 into root 3 in the numerator, and in the denominator, we have root 3 into root 3. What is that? 3. Beautiful. So now we can cancel it, right? To reduce. So it is 3 ones and 3 40s. So we have AC is equal to 40 root 3. But you know what? We know the value of root 3. It is known to us. It is 1.73. So we substitute that value of root 3 there. So we get AC is equal to 40 into 1.73. Now you multiply that and we will get AC is equal to 69.2 meters. So we got the length of AC. That means now we can say we got the length of the string, and so now we can write the final answer there. Therefore, the length of the string is 69.2 meter, and we got the sum. Wasn't it easy? Very simple, right?